Thank you, Alex. Hi, all. Okay, so my talk is something like the same what Jose presented, but from different point of view. So it also about stages, but when Jose talks about GenStages, he talks about flow and about data processing. My talk will be more about application design, software design, or program design. So I want to show how one can use such perfect feature as GenStage, not only for data processing, but for different approach to design their programs and their software. So my name is Anton. I am Ruby developer at Matic Insurance. I'm Elixir fan since 2013. I'm known a little in Elixir community as author and maintainer of eSpec, behavior-driven development test framework. You can find me on GitHub. So what is the problem? I think that not only this is not only my view on the problem. So I think that most of us are noticed that something wrong with our software and something wrong with the way we write the software. The way we are writing software now, not me, but the author of FlowBased programming called conventional programming. So our programming languages, no matter is it object-oriented programming language or functional programming language, are called conventional programming language. And what is the problem with this programming language? The first problem is that your code is procedural and sequential. So no matter are you calling a method on object or are you calling functions on some model, your program is just a sequential evaluations of methods or functions. So in such approach, parallelism is not native for programming language. What I mean when I say that parallelism is not native, I mean that when you design your program, you don't think about parallelism. You just think about sequential evaluation of your code, and then you start thinking about how make this code parallel. So how just to run several instances or several threads or several processes that will evaluate this code. But approach approach remains the same. Approach remains sequential. The next problem is hierarchical structure of our programs. So this sequential code evaluations makes our programs. Our structure of our programs is very hierarchical, and we think not more about how we process some data, some input, but we think more about how to build this hierarchical structure. And the last point is visualization of our programs. For me, one should easily understand what program does, and if some of you tries to write, to draw a program, some object-oriented program on some whiteboard, I think you will fail. So there is no simple way to visualize what your program do in object-oriented programming. In functional programming, the situation is a little better, because in functional programming we have sequential functions call, and we might draw some circles, but the problem still is. So we need alternative approach for writing software. So we need alternative approach for writing software, and we discussed what is flow-based programming, and I will say a few words today. So details we can find on slide share. The goal of this talk. The first thing is to discuss, the goal of this talk is to discuss a special case of flow-based programming. I call this case railway flow-based programming. It is nothing with Ruby Rails, it connected with railway for trains. The next goal is present Flowex library. It's a little like proof of concept, which allows easily to create programs in railway flow FPB approach. And of course shows that Elixir GenStage is not only about data processing, but about software design. Okay, so what will be about? We discussed shortly what flow-based programming is. Then we discussed what is railway-oriented programming approach. Flow-based programming is like about programming paradigm. Railway-oriented programming is like a pattern in functional programming. Then we mix them together and discussed railway flow-based programming, and then I will present Flowex library. So let's start. What is flow-based programming? Flow-based programming, it's a programming paradigm that defines application as network of black boxes that can communicate via passing data or AP packages. Flow-based programming will invited, I don't know, by John Paul Morrison in about 70s of previous century. You can find more details in his book, Flow-Based Programming. So this is a diagram to illustrate what flow-based programming is. So when you write your program using flow-based programming paradigm, your program is a set of processes, something like black boxes. Each of the processes they called component. Each of the component has one or more input or one or more output. And what your program does, it just accepts data as input for this component. Each component process data in some way and send to another component. Another component process data in some way, send to another component, and then we have the result. So the paradigm states that you must try to think about your problem and try to realize it in such a way that you have some independent component and you have data that will pass through this component from input to out. A good example from a presentation of Mr. or Dr. John Paul Morrison is a bottling factory, just to illustrate how flow-based programming works. So in the bottling factory, each component just do some work, and there are components are fillers, capper, and labeler, and the bottles here is like data that passes through this component. In flow-based programming, this data called IP, informational packages. Informational packages are passed through the first component. They fill. The data passed to the first component. They fill it by water. Then the data moves to the capper that cap the bottles, and the last component puts the labels. Yes, so the program is just passing data through sequential components. What is cool in such approach? In such approach, there are some pros in such approach. The first of all is that each component is independent and reusable. So when you designed one component, you can place this component in in any place of your program, you can mix this component and to get the result. Each component, by design, when you design component, you think about components. You think about the interface. So the interface are clean enough. Yes, something about side effects. Yes, and you as designer, you can design in two ways. You can design one component and just to design logic which will modify the AP packages pass through this component, and or you can, as designer, you can sit at you can move with data package and design which transformation this data package will be affected. And the main pro of this approach, I think, is a native parallelism. Again, what I mean native parallelism is that flow-based programming is parallel by default, because each of your component is an independent process, and all the components are evaluated simultaneously. So you don't need to think how to parallelize your algorithm, because when you design your program in such way, you get a parallelism by default from out of the box. Oh, sorry. So that was about flow-based programming. Now a few words about railway-oriented programming. Railway-oriented programming is a design pattern in functional programming language. The idea of this design pattern is design your functions and data structures in such way that evaluation of your program is just sequential evaluation of a set of functions, and you can pass an output of one function to the input as an input to another function. Simple example is on the slide. So we have requests like something like data structure, some data structure. We pass this request to validate request function, and the output of this function we pass to the get user function, and so on and so on. So it's a very simple pattern, I think. So again, the idea is just to design your function in a way you can simply connect them one after another, like in railway. So what name states. Just to make your program in railway-oriented programming, you just need to think about interface of your functions. So each functions, so they can be connected together. For example, in Elixir and Erlang, for communication, we use tuples OK with some data when we have success result, or error with some failure message when we have error result. Yes? OK, and some pictures from presentation on, I forgot. Forgot the name of this guy, but you might follow the link. There are a lot of information about this approach. So the illustration is on the slide. We have one function that can be success or error, and when we defined an interface of communication between them, we can connect them together. So no matter what first function return, it always can be connected to the second function. And our program, for example, our web server, can be presented something like this. Data just validate, then update DB, then send email. A good example of this approach is Elixir plug library. So if you know, each plug is just a function which accepts a connection struct and should return a connection struct. So the simplest web server based on plug just receives data from, for example, Cowboy server, put the data into this plug structure, all the data about request, cookies, host, method, etc. Then this struct passes through the plugs from one plug to another, and the last plug returns this plug connection to Cowboy server, and Cowboy server returns it to the client. The next one more example is from Ruby community is a rec. If you know what is rec middleware, every rec middleware should implement a call function. This call function receives environment object and should return this environment object. And you easily just combine this rec middleware, and your request passes through this rec middleware. Okay, that's it about railway-oriented programming, and now the idea is to mix these two approaches together. I'm sure you get the idea. So the idea is to transform each part of our railway of function, and wrap each function into FPB component. So we don't have a sequential evaluation of functions, but each function will be evaluated in separate process. So our program will looks like this. So it's not this function will not be evaluated in one process. Each function will be evaluated in another process. So and our data structure we want to process will pass through to the first process, then the result will pass to the second process and to the last process. Yeah, I think the idea is clear. Yeah. Okay. So why we need Elixir to implement this simple idea? The first thing, of course, is Elixir GenStage, because Elixir GenStage helps us to implement communication between processes in that way that they will not overload each other. So the main feature of GenStage is back pressure mechanism, which allows us to build a chain of processes and don't worry about communication between them. Okay, you know already what GenStage is. William just talked. And the second feature of Elixir is awesome feature is metaprogramming, which allows us to simply sharing functionality between our modules, yes, and allows us to create beautiful DSL. Okay, so meet Flowex. It again, it's just a proof of concept. I published it on Hex less than 1 month ago. Version is 0.1.1. And to understand how to use Flowex and what you can do with Flowex and how you can use a railway flow-based programming paradigm, I propose you to consider an example. Example is not very difficult. We just wanted to write a set of functions to calculate a simple mathematical expression, number plus 1 multiplied by 2 minus 3. I defined 3 different functions for each of this operation. Each function accepts a struct. The struct also defined in these model functions. There is a number in the struct, and there are also A, B, and C keys. These keys are there to demonstrate how options works. You should don't care for now. So what add1 function does? It accepts a struct and to the number of the struct plus s1 and return the same struct with number as a new number and sets option A for this function. This function do almost the same. It just multiply number by 2 and returns this modified structure. and -3 do the same. So why these functions are cool? Because they have a similar interface. All three functions accept the same structure and options, and all three functions return the same structure. So we can easily use this function in, for example, such way. We just create structure with some initial number, and then pass the structure to the first function, pass the structure, the result path to the second function, and the result will be passed to the third one, and we have a result. If you define function in such way, use Flowex is very simple. You just use Flowex pipeline here in the top, and uses these three macros pipe. These three macros are defined which of your functions will be placed in a separate process. So when we write pipe add 1, pipe multiply by 2, and pipe -3, we ask Flowex to place these functions into separate process. And again, declaration of the functions remains the same, definition of the structure remains the same. So just these 4 lines of code allows you to create a pipeline of the processes. And I renamed module to fun pipeline because now we are building a function pipeline. And what happens when we use Flowex pipeline? It's Elixir magic, as you know. So first of all, this line of code adds pipe macro. Yes, and this macro allows us to mark which function will be placed into a separate GenStage process. This line defines start and stop functions for creating and destroying Flowex pipelines. So for starting these GenStages and for stopping these GenStages. And of course, it defines run function, which will be used to perform calculations. Okay, so to start pipeline, you just use function start, which is defined on this fine pipeline model, and you can pass options to this function. And what happens when you start a pipeline? You started 5 GenStages. Each GenStage for one GenStage for each of the function, add 1, multiply by 2, and -3, and 2 additional GenStages, 1 producer and 1 consumer. Producer will pass data to this pipeline, consumer will consume the data. And all of the stages are placed under a supervisor. Okay. The function start returns pipeline structure. A few words about this structure. This structure has all we need to run our calculation in the pipeline. First of all, this structure of our model, fun pipeline. It has a name of producer, which is at the beginning of our pipeline. It has unique name of our consumer out name, which is at the end of our pipeline. And also this structure has a process identifier of supervisor, just to start and stop that pipeline. Okay. To run the calculation, one can use run function. You just pass the pipeline to as the first argument and a structure you want to be processed in that pipeline. And this operation returns again the same structure but with modified field. 2 plus 1 multiplied by 2 and -3 will be 3. Yeah? And options always were set, as you remember, also were set. As you remember, each function set one of the options. Okay, let's move on. Another way to run the calculation is using Flowex client. What is a Flowex client? Flowex client is just a Gen server, a simple Gen server that can run calculation on that pipeline. Why we need clients, you will see a little bit later. So to start a client, you just use start function and pass the pipeline to that function. You get client pit, and then you use Flowex client run function to run calculation, but now you pass to the function the client pit, and the structure will be processed in that pipeline. Okay. How it works in details, again, to understand what happens when we run calculation. Here is your self process, the process from which pipeline is called. This self process is passed the structure to the Flowex client. Flowex client pass this structure to the pipeline. Inside the pipeline, this structure are wrapped by Flowex IP structure. This Flowex IP structure has an initial structure, and some metadata needs to communicate these processes between each other. So when the number moves to producer pushes to add one function, add one process, add one component. Add one component pushes the modified structure to the multiply by 2 component. Then this component pushes to -3 component, then to consumer. Then structure returns to Flowex client. The Flowex client returns it to the calling process. It's clear. Okay. One should understand which operation are synchronous in this implementation and which are asynchronous. Communication between Gen servers are asynchronous by default, but when client call calculation in pipeline, this operation is synchronous. So client just sent one informational package and wait until this package moves through this pipeline, and then client sent it to our self processes. And I think some of you can ask, is there no parallelism in such implementation? Yes, because when client passes one package, we can't pass another package, IT informational package, until this package moves through the pipeline. But the answer is there can be a lot of clients. So why this abstraction of Flowex clients exists? Because one can attach many clients to one pipeline, and each client may push informational package into the pipeline. So when first client push one package, one IP to this component perform calculation, pushes them to next component, and at this point, another client can push the data. Data move downside, and another client may push data. So in this implementation, where when you use a lot of client, each component do this work at the same time, and you have native parallelism as in flow-based programming. Okay. And about bottlenecks, what if there is a very slow process in pipeline? Yes, if some of the processes are very slow, for example this one, and there are many clients that are that push the data to the pipeline, this data will not be processed until this process processed his informational package. Yes, so this process became a bottleneck. But Flowex allows you to add some more magic. one can specify the number of GenStages which will process data in parallel. How many GenStages will do the same operation. For example, for my implementation, I wanna that one GenStage for add one function. I wanna create 3 GenStage for multiply by 2 function, and I wanna create 2 GenStages for minus 3 operation. And with this interface, when you run Flowex this pipeline, you get something like this. So each of the function will be duplicated as many times as you want, and each of the GenStages will be subscribed. It's next of each of the next GenStages will be subscribed to the all previous one. So if, for example, this operation is very slow, then the first package moves here. There is hard work here. When arrives the second IP, it moves here. When arrives the third, it moves here, and again and again. It's clear, yeah? Okay. And the last thing, but very important, is how we can create reusable components with Flowex, with such approach. Because before, we just need to define function in each module, which will be a pipeline, which will become a pipeline. But one can easily define module pipelines. What is module pipelines? Module pipe. What is module pipe? It's a module which implements 2 functions. It's just like a plug module, a need function and call function. For example, this module will become a component to adding for adding one to our structure. So a need function just accept options and can modify these options, and the call function do the job. It's just add one. In this approach, you can define a pipeline in this way. You use Flowex pipeline, but when you define your pipes, your component, you pass module names to the pipe macro. In such way, you can define these components independently and reuse this component for different pipelines in your code. And of course, one can mix module pipelines and function pipelines. For example, for some specific case, one can add here pipe with some function, and this function should be defined in this module. So you can reuse these components with some modifications. That's it. And conclusion, why it's cool. First of all, it's my opinion, of course, this approach to writing software is easy to understand. So when we defined a pipeline module, first of all, we explicitly defined a structure of our data. So a pipeline can accept only data of defined structure. So you can't pass another structure. You can pass only this structure which has number field A, B, and C. So your pipeline defines the structure it is working on. The next is pipeline explicitly define a way data will come. When you look at your pipeline module, you see one pipe, another pipe, the third one, again, and you can see all the steps your data will pass. And your pipelines explicitly define a parallel executor structure. You explicitly defines how many parallel GenStages will be spawned for each pipe. I think that explicit is better than implicit. The next thing is it's easy to maintain and reuse. So again, it's like in flow-based programming, you have a predefined set of components in program. Each component is isolated, and you can reuse the component. So you use the user modification or some extraction from a database and reuse this component in many pipelines. And the last one, it's not a scientific term, is about, I call this control parallelism. So one can control number of clients supplying data to pipeline. So you explicitly defines how many clients will push data to your pipeline. And another is that one can control a number of processes available for each component. And so user or programmer, which implements the algorithm, can control the parallelism of its program. That's it. Thank you. Questions?
What about conditions inside the pipeline? Should it be like a Haskell implementation of either or something like that?
About conditions inside the pipeline.
Yeah, if number less than 0, it should be multiplied by -1. If greater, then divided by 2.
So inside the pipeline, you just have a function.
Yeah, it should be implemented inside the function.
Yes, so you just implement a function which will be in each component, and in this function you can place any logic. So what is the good thing to say about Flowex is that if your function if functions in your code have a similar interface, you can easily use Flowex from now. So you just use Flowex pipeline and automatically wrap your functions into Gen server.
Okay, thank you.
Could you please explain what happens when stuff goes bad and unexpected errors occurs in functions in your components?
The question was what will happen when things goes wrong. It's the same question I asked Jose. So it's the same situation with GenStages. So in Flowex, your GenStages are under supervisor. So when one of them crashes, supervisor will produce one more processes and place it to the pipeline and subscribe these processes to another one. So in theory, all should be fine, but in practice, in current implementation of Flowex, there are no proper error catching. More questions?
What about the order of flows in pipeline? I mean, does it ordering by how you how you write macros names?
Exactly. So the idea is the idea is to build a railway flow-based programming. So your components are just one after another, and the sequence is like you define here. So add one will be first, the next, and the third.
Can I ask a stupid question?
Of course.
English. Perhaps the protocols can help us to make a decision between two separate modules or not. I mean that would be great to have two conditions and two way to go through the pipeline, yeah, in a positive or negative question. Perhaps protocols can help with it, no?
I need to think about the protocols, but as I see this approach, that everyone should think about how to build the program in such way that you don't even need to place your data to another flows. And if you, for example, if you really need to place your data into another pipelines, you may put this logic outside or logic outside pipeline. Because in this approach you can write program as you write before, but some parts of your programs you may rope to pipeline.
It's not scalable. That's because we have a branch of it which should return to main workflow, and this branch will be can be scaled in this way, if you understand.
But you can create many pipelines, many similar pipelines with a lot of clients for this pipeline.
Contain a list of a pipeline which will contain another one pipeline, and it will be branched.
You mean when a function from specific component calls another pipeline? Yeah. Again, I think that it's bad design. So it's cool design if you can do this right, like in Railway. Yes. Thank you very much.